Hello students, today we will see very important topic that is isomerism. So this is very important topic. You must definitely understand the concept as one question will definitely come in the exam. So what are isomers and what are isomerism? So the organic compounds which have same molecular formula but they show different structures, and due to their difference in structures they show different physical properties and different chemical properties. So these different structures are known as isomers, and this phenomenon is known as isomerism. So ऑर्गेनिक कंपाउंड्स जिसकी मॉलिक्यूलर फॉर्मूला तो सेम होता है लेकिन उसके अलग अलग स्ट्रक्चर्स बनते हैं, और अलग अलग स्ट्रक्चर्स के कारण उनकी फिजिकल प्रॉपर्टीज और केमिकल प्रॉपर्टीज भी अलग अलग हो जाती है. सो अलग अलग स्ट्रक्चर्स को हम आइसोमर्स बोलते हैं और इस फिनोमिनन को हम बोलते हैं आइसोमेरिज्म. So different structures means they have difference in the arrangement of carbon atoms in their compounds. So कार्बन एटम्स की अरेंजमेंट अलग अलग हो जाती है, इसीलिए हमको अलग अलग स्ट्रक्चर्स बनते हैं और अलग अलग स्ट्रक्चर्स के कारण प्रॉपर्टीज भी उनकी अलग हो जाती है. Let's see some examples of isomerisms. Iso means same, meros means apart, means they have same molecular formula. So isomerism is possible only with hydrocarbons which are having 4 or more carbon atoms, because only then they show different structures of different arrangement of carbon atoms in them. So general formula, how we know how many isomers we can make for a particular compound. So for a particular organic compound, a hydrocarbon, the general formula is 2n minus 4 plus 1. So where n is the number of the carbon atoms. So number of the carbon atoms, if we will put, we will get the number of isomers. So the first three members of the alkane family, that is methane, ethane and propane, will not show any isomerism because they have the same structure. We cannot make more than one structure. So पहले three members जो होते हैं alkane family के, मीथेन, इथेन और प्रोपेन, इनके आइसोमर्स नहीं बनते क्योंकि इनकी जो स्ट्रक्चर्स होती है वो समान नहीं होती, उनके दो स्ट्रक्चर्स नहीं बनते हैं. मीथेन, सो मीथेन का फॉर्मूला है CH4, मॉलिक्यूलर फॉर्मूला है CH4. अब इसका हम स्ट्रक्चर देखते हैं. कार्बन इज अ टेट्रावेलेंट, सो इट हैज 4 हाइड्रोजन इन द आउटरमोस्ट शेल. सो दिस इज द मीथेन. इसके एक ही स्ट्रक्चर बनेगा, इसका दूसरा स्ट्रक्चर नहीं बनेगा, इसलिए इसके आइसोमर नहीं बनेंगे. अब मॉलिक्यूलर फॉर्मूला ऑफ इथेन इज C2H6. So let's draw the structure of ethane. So we all know carbon is tetravalent, तो यहाँ हाइड्रोजन लगाएंगे, हाइड्रोजन 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 हाइड्रोजन. ये इथेन का स्ट्रक्चरल फॉर्मूला है. So we cannot make another structure. So there is no isomers possible in ethane. Next is propane. Propane is C3H8. So इसके भी structures हम अलग नहीं बना सकते. It will also have the same structure. We cannot make another structure. So it will not show any isomerism. So the first three members of the alkane series, methane, ethane and propane, will not show any isomerism. We will not get any isomers for these first three members of the alkanes because they have the same arrangement of carbon atoms. Let's see the isomers for the butane. So we have just now seen the general formula 2n minus 4 plus 1, where n is the number of carbon atoms. So in butane, the molecular formula is C4H10. So the number of carbon atom is 4. So we will put 2 4 minus 4 plus 1. 2 to the power 0 plus 1. So 2 to the power 0 means 1 plus 1, that is 2. So the number of possible isomers in butane is 2. So first N-butane, we will see the molecular formula is C4H10. the structural formula 1, 2, 3, 4 carbon. Then put all hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C4H10. This is butane. You can write it in this in another way also. CH3, CH2, CH2, CH3. So this is one structure of butane, one isomer of butane. Next isomer we will just change the arrangement of the carbon atoms. 1, 2, 3, again this. The carbon is tetravalent, put all hydrogen atom. Hydrogen here, hydrogen, 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 hydrogen. Now count how many carbon atoms. 1, 2, 3, 4 carbon. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the molecular formula is same C4H10, but there is a difference in the structure, difference in the arrangement of the carbon atoms. In the second carbon atom, we have kept the methyl group, CH3 group. This is the methyl group. So this is known as 2-methyl propane. The IUPAC name is 2-methyl propane, and since branching is only one carbon atom, so it is known as common name is isobutane. This structure we can write in different way also. We can write like this also. CH3, CH, CH3, CH3. So both the structures are same. So only we can make two structural isomers for the butane. Next example we will see for the pentane. So pentane, the molecular formula is C5H12. So pentane is an alkane. So we know the general formula CnH2n plus 2, where n is the number of the carbon atoms. So number of carbon atoms is 5 here. So the molecular formula is C5H12. So how many isomers is possible in this? So just put the form in the formula 2 n minus 4 plus 1, where n is the number of carbon atoms. Here number of carbon atom is 5 minus 4 plus 1. So 2 to the power, how much it will be? 1 plus 1. This is total 3. So hence we will get the total isomers for the pentane is 3. So first pentane. Let's write the structural formula for pentane. We have 5 carbon atoms and then all we have hydrogen atoms. Put all hydrogen here. This formula we can write in another way also. CH3, CH2, 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 CH3. So this is one isomer of the pentane. Next, isopentane. So we have same molecular formula. So isopentane means only one branching will be there. So hydrogen, 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 hydrogen. So count 1, 2, 3, 4, and total we have 5 carbon. So branching is in the second carbon atom. Only one branching is there. And total hydrogens, if we will count, it will be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 5 carbon atoms and 12 hydrogen. So molecular formula is same. In the pentane and the isopentane, only one branching is there. That is why we are saying it as isopentane. And the IUPAC name is The branching should get the lowest number. So we are counting the carbon from this right side. So the IUPAC name will be 2-methyl butane because the longest carbon chain is 4 here and branching is in the second carbon, methyl group in the second. So the name is 2-methyl butane. We can write this structure in another way also. CH3, CH2, CH, CH3, CH3. So both the structures are same only. So both ways we can write. So this is the another isomer of the pentane. Another isomer of pentane is neopentane. Let's draw the structure. 1, 2, 3. In the second carbon, we are putting 2-methyl group. So all the 4 valencies of carbon are satisfied with hydrogen. So let's write 1 hydrogen, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 hydrogen. So 5 carbon atoms are there and 12 hydrogen. So the structure is different. So it is one of the isomer of the pentane. So the name of this isomer is neopentane because we have 2 branchings on the same carbon atom, 2 methyl group on the same carbon atom. That is a second. And the IUPAC name is, we will take the longest carbon chain, that is prop. So propane, CC is a single linkage, so propane. So we have 2 methyl group. So the IUPAC name will be 2,2 hyphen dimethyl propane. This is the IUPAC name. The same structure, you can write it in another way. CH3, C, CH3, CH3 and CH3. So this is the another isomer of the pentane. So how many total isomers of pentane we have seen? We have seen the 3 isomers of the pentane. So one was the normal pentane, another was the isopentane, and another one was the neopentane. Now let's see another example for the hexane. So how many isomers are possible for hexane? Let's see from the formula 2n minus 4 plus 1. So 2, number of carbon atom is 6 minus 4 plus 1. 6 minus 4 is 2. 2 to the power 2 plus 1. That is 4 plus 1. That is 5. So the total isomers for hexane is 5 isomers. Let's draw the structures for that. First is normal hexane. So 6 carbon atoms are there. Then put all hydrogen. Carbon is tetravalent. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 6 carbon atoms and 14 hydrogen atoms. So this is the one isomer of the hexane. The same formula we can write like this. CH3, CH2, 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 CH2 and CH3. So 6 carbon and 14 hydrogen. This is one isomer of the hexane. Let's see another isomer of the hexane. So another isomer of the hexane is, we will just change the structure. Molecular formula will be same, but structural formula will be different. So we have 1, 2, 3, 4, 5, 6 carbon and say hydrogen same 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So C6H14 is there, but there is a difference in the arrangement of the carbon atom. In the second carbon atom, we have kept the methyl group, the side chain. So the total will be the C6H14 only, but the difference is in the structure. So we got another isomer here. So the name of the compound is, we will first check the longest carbon chain. So longest carbon chain is the 5, and since all have CC single bond, that is, it is an alkane, and the methyl group is in the second carbon atom, that is act as a side chain or the substituent. So the name of this compound is 2-methyl pentane. The same structure we can write in different way also. CH3, CH2, CH2, CH, CH3 and CH3. So another isomer of the hexane. So 1, 2, 3, 4, 5. And now we are putting methyl group in the third carbon atom. So total carbon 1, 2, 3, 4, 5 and 6. Carbon and hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So total carbon is 6 and total hydrogen is 14. Means molecular formula is same, but here structural formula is different. Now we have kept the methyl group in the third carbon. So count 1, 2, 3, 4, 5. So the longest carbon is, 5 carbon, and the methyl group acts as substituent is in the third. So the name of this compound is 3-methyl pentane. This we can write in another way also. CH3, CH2, CH, CH3, CH2, CH3. So hence we can say, what is the name of the compound? 3-methyl pentane. So this is another isomer of the hexane. Let's see another example, another isomer of the hexane. So 1, 2, 3, 4 carbon atom is there, and we will put methyl group in the second. So 1, 2, 3, 4, 5, 6. Total carbon is 6. Now hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 6 carbon and 14 hydrogen. So molecular formula is same, but structural formula is different. And the naming of this compound is 2,3-dimethyl butane, because the longest carbon chain is 4, so but, and CC linkage is single bond, so alkane. So the name of the compound is, this is a methyl group, this is also methyl, so it is in the second carbon and third, so 2,3-dimethyl butane. This you can write in another way also. CH3, CH, CH3, CH, CH3 and CH3. So both are same only. So this is one isomer of hexane. Let's see another isomer of the hexane. 1, 2, 3, 4. We will put the methyl group in the second carbon atom. 1, 2, 3, 4, 5 and 6. So total is 6 carbon and then hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So here total hydrogen is 14, total carbon is 6. It's another isomer of the hexane. So the name is the methyl group. 2 substituent group is in the second carbon atom. In the second carbon atom. So the name of the compound is 2,2 dimethyl butane. So this is another isomer of the hexane. We can write it in another way also. The same thing, another CH3, CH2, C, CH3, CH3 and CH3. So both are same only. So this is one another isomer of hexane. So this is how we can make the different isomers of the same compound. So let's have a quick recap. So what are isomers and what is isomerism? So the compounds which have same molecular formula but they have different structures, and these different structures are known as isomers, and this phenomenon is isomerism. Due to these different structures, they show different physical and different chemical properties. Thank you very much.